Hello everyone, and welcome to the lecture on for loops. So in this lecture we're just going to learn about for loops, and you can see here I have the Jupyter notebook, and the for loops are going to help us iterate through any items that are a sequence in Python, or really any items that you can iterate over. So you can see here I have the Jupyter notebook. We're just going to go through a bunch of examples, and we'll introduce two new topics along the way, and these are all the examples we're going to work through. So let's go ahead and cut to a very brief presentation just to break down what a for loop is, and then we'll get started with some live coding and the for loops. Okay, so let's go ahead and jump over to the presentation. Great. So for loop statements. So a for loop can act as an iterator in Python, and what it does is it goes through items that are in a sequence or any other iterable item. So if you remember these objects we covered in the objects and data structures section that we've learned about that we can iterate over, those items include strings, lists, tuples, and then we can also iterate over the built-in iterables in dictionaries, such as keys or values. And we'll break down that topic later on in this lecture. So the general format for a for loop in Python is going to look a little something like this. You're going to say for item in object, colon, next line you're going to indent and say statements to do stuff. Now if you're in any IDE or if you're in Jupyter Notebooks, this sort of indentation is taken care of automatically for you. So again, the format is going to be for item in your iterable object, colon, and then you're going to have some code to do stuff. So that variable name that I used, item, is actually completely up to the coder. So you're going to be able to just choose a name that makes sense to you, and hopefully you choose one that you're going to be able to understand when you're revisiting your code in the future. And then that item name can also be referenced inside of your loop. So for example, if you wanted to use if statements to perform checks. So that's the presentation. Let's go ahead and hop back to the Jupyter notebook. Great. So we're back, and we're going to go ahead and get started through a very simple example. So now we're going to start with some live coding. I'm going to make a list, and this list is just going to be the numbers 1 through 5. So I have my list L. So L is equal to 1, 2, 3, 4, 5. And now I'm going to say a for loop. Let's say I wanted to print every element in that list. I could say for elements in L, colon, I'm going to click enter. It's automatically going to indent for me. I'm going to say print elements. Shift enter to run that cell, and you'll notice it went ahead and printed each of those elements. And to drive the point home that we can actually name this item, variable name, whatever we want, I'm going to go ahead and switch it here. For num in L, print num, and you notice it's the exact same thing when I run it. So what's nice about this is within your for loop, before it, you don't have to worry about predefining that num, and you can then reference it inside of your for loop. Okay, so let's go ahead and do something a little differently here. What I'm going to do is I'm going to say for num in L, print something. Oops. So what this is going to do is you're going to tell Python, hey, for every number or every element in that list, I want you to do the code below, which is print something. So it should print something then 5 times. And there you have it. So you can imagine we could have lots of code here in this space, and it'll do it for every element that's in that iterable or that list. Okay, so that's our simplest example. So we're going to build on top of this, and we're going to write an if statement within that for loop that can check for even numbers. So in order to check for even numbers, I'm going to introduce a new concept called the modulo, which is spelled M-O-D-U-L-O. And what this is going to allow us to do is get the remainder in division, and it uses the percent symbol. So I'm going to show you an example. So imagine I have 10 divided by 3. So what would the remainder be? Well, 3 times 3 is 9, and so 3 goes into 10 3 times, remainder 1. So that means when I type this in, 10 modulo 3, or sometimes called mod 3, 1 is my remainder. So I have 3 remainder 1. And let's say I wanted to do just another quick example, 18 modulo 7. So 7 can go into 18 2 times with a remainder of 4, because there's going to be 14. 7 times 2 is 14, and then in order to get up to 18 you have a remainder 4. So that's what we output there. And let's just drive the point home with 4 mod 2. So 2 actually goes in evenly into 4, so you have no remainder, 0. Okay, so go ahead and make sure that this makes sense to you by typing in examples, but basically all that modulo is doing is it's just giving you the remainder that's left. Okay, which remember, that's not equal to the decimal point after the number. That's just a remainder, as in a super basic kind of elementary division. Alright, so moving along, we can notice that if this number is fully divisible with no remainder, then the result of the modulo call is 0. So that means we can use this test for even numbers. So we can think that if we get a 0 output from this percent sign or modulo 2, if that's equal to 0, that means it's an even number, right? Because if 2 goes into your number evenly, then you know that number is even. And if it outputs a 1, then you know you have an odd number. So let's go ahead and go back to that for loop we were doing. So I have L, which is 1, 2, 3, 4, 5. And go ahead and say for num in L, colon, and then I'm going to have an if statement. I'm going to say if num modulo 2 is equal to, and notice how I have 2 equal signs because I'm making a comparison statement here. So I'm saying if that number is absolutely equal to 0, colon, print the number. So let's go ahead and break down what this is going to do. It's going to go through each of those items in that list, and then it's going to say, okay, grab that item, which in this case is a number, perform mod or modulo 2 on it, check if it equals 0, and if that's the case, then print that number. So go ahead and see if that works. Awesome. So you notice we only printed the even numbers. And so what would happen if we set this equal to 1? Let's go ahead and find out. We only print the odd numbers. Excellent. So let's go ahead and build on top of this and add an else statement. So I'm going to set this back to 0, so it only prints odd or even numbers, excuse me. And I'm actually going to change this. I'm going to say print here is an even. And remember, this sort of print statements are for Python 2. And then I'm going to say else print odd number. So take a moment, make sure you understand what is going to actually output from the cell, and then check if you're right by running it. Okay, great. So let's go ahead and do one more edit to this code. So I'm going to say, let's say I want to actually print the number if it's even. So I'm just going to print the num here, and then if it's odd, print an alert that was an odd number. Let's go ahead and run that cell, and you notice I get odd number to odd number for odd number. Keep this in mind, because on your test there's going to be a question that kind of uses this sort of logic. It's going to be called the FizzBuzz question, and it's actually a really common interview programming question as one of the first screens you do. Okay, so moving along, we're going to go with a totally different example now. So another common idea during a for loop is keeping some sort of running tally during the multiple loops. And for example, what we're going to do is create a for loop that sums up that list. So let's go ahead and make a list. Actually, we already have our list, L, 1, 2, 3, 4, 5. And I'm going to make a variable called list underscore sum. And I'm going to set it equal to 0. Okay? And then I'm going to do a for loop that says for num in L, take my list sum, and I'm going to set it equal to the current list sum plus that number. And then after the for loop has run, I'm going to print list sum. And notice how this statement right here is outside of the for loop because it's not indented inside of it. Okay, let's go ahead and run that. And I get 15. So that makes sense. So basically what happened is 1, 2, 3, or yeah, 1 plus 2 plus 3 plus 4 plus 5 is going to be equal to 15. So let's break down what's going on in this cell so we really understand it. I'm setting a variable, list sum, and I'm setting it equal to 0 outside of the for loop before the for loop takes place. And then I'm saying for every number in that list, go ahead and take the current list sum and then add that number to it and reassign list sum. So it's doing this code again and again for each of these numbers. And you'll notice list sum is then acting like a current running tally for your current sum. Okay, great. So read over that cell, make sure you fully understand what's going on. And something I want to note that we've gone over before is if we're editing a variable by itself, we can also use this sort of notation, this plus equals. And you'll notice if I run that cell, it's going to equal the exact same thing. Okay, great. So let's go ahead and move on to another example. So we've already looped through lists, and now we're going to loop through a string. So I'm going to say s is equal to this is a string. Okay, perfect. So remember when we index strings, Python thought of them as a sequence. So now when we iterate through them, we'll also be accessing each of those items in the string. So I can say for item in s, that string, print item. Shift enter, and you'll notice it's going along the 0, the 1, the 2, the 3, almost as if it was indexing it, and then it's printing every single item in that sequence. This is a string. Great. So right now, if I was to do this in my own code, I would have called this something that makes sense to me. So for instance, letter makes a lot of sense since I know I'm going through the letters, and I'm going to say for letter in s, print letter. And you notice the output is exactly the same. Okay, so now let's go ahead and look at how a for loop can be used with a tuple. So I'm going to make a tuple. I'm just going to call it tup. And remember, tuples are with parentheses, and I'm going to use 1, 2, 3, 4, 5. And I'm going to say for t in tup, print t. So you notice it's iterating it just like as if it were a list. It just cares that it's a sequence. And we can also, again, call these whatever we want. Okay, great. So something that's interesting about tuples, and this is where we're going to get a little more advanced than in a typical lecture, we're going to learn about something that's called tuple unpacking. And to fully show that, what we're going to do is create a list of tuples. So I'm going to redefine L to be equal to a list, and what I'm going to have it do is create some tuple pairs in that list. So 2, 4 is going to be an element in that list. 6, 8. So you notice I'm kind of nesting these tuples inside of that list. And then 10, 12. Okay, so what's going on here? I have L, which is a list of tuple pairs. And to show you what that looks like, let's go ahead and index the 0th item. That's going to be that pair, that tuple, and I can, again, if I wanted to, index again and say that's just 2, so 0, 0. And then I could say 1 to grab 4. So let's say we wanted to grab 10. Hopefully this is familiar to you. That would be the second index of that list, and it's going to be that first item, and there we have 10. Okay, so now that we have that sort of logic down, we can actually do what's called tuple unpacking. So if you're iterating through a sequence that contains tuples, and the item can actually be the tuple itself. So during the for loop, we will be unpacking that tuple inside of a sequence, and we can access the individual items inside that tuple. So I know that was a lot, so let's just go ahead and show you an example. So first I'm going to say for tup in L, print tup. Okay, so that makes sense, right? I'm printing every element in that list. And now I'm going to show you how to do it with unpacking. So if I know what my data structure looks like inside that, and it's a tuple, I can actually write something that looks like this. I can write that item that I'm iterating with as a tuple. And I can say for this tuple in L, print, let's just want to print the first ones, the 2, 6, 10. And now this is called tuple unpacking. So with tuples in a sequence, we can access the items inside of them through this unpacking. And the reason that this is really important is because a lot of objects will deliver iterables through tuples. And what we're going to do now is start exploring iterating through dictionaries so we can take this concept a little further. So just to break down what we did, we said for tup in L, we printed tup, and that will output the entire items in that list. But if I state that item to look like a tuple, this T1, T2, and remember I have to match it up exactly to what all those items look like in the list, so the items have to be uniform, then I can print things from that actual tuple. So I could do something like this as well. Or then I could perform operations on it. So I could say, maybe I wanted T1 minus T2. And I get -2 for all of them, or let's say I wanted the sum of them, 6, 14, 22, etc. Okay, so let's go ahead and expand on that idea by working through a dictionary. So I'm going to say D is equal to, let's go ahead and make a quick dictionary here. I'm going to make 3 keys, K1, K2, and K3. Great, so now I have my dictionary, 1, 2, and 3. We have 3 keys, K1, K2, K3. And I'm going to say for item in D, that dictionary, print item. So what do you think is going to come out? It's actually just the keys. And notice how they're also out of order. Remember, dictionaries are mappings. So what's going to happen here is that this is only producing the keys. And what do we do if we want to get the values, or both the keys and the values? So we're actually going to have a Python 3 alert. So let's go ahead and jump back to the Jupyter Notebook. Okay, so jump back to the Jupyter Notebook to fully discover this Python 3 alert. So if you're using Python 2, the method we're going to use to iterate through the items is called .iterItems. So if you're using Python 2, you should use .iterItems to iterate through the keys and values of a dictionary. So what this does is basically creates a generator, and we're going to learn about generators later on in the course, and that's going to generate the keys and values of your dictionary. So to see it in action, I'm just going to walk through the code here. I have d.iterItems, and we can see that this creates a generator. So calling the items method returns a list of tuples, and then you could iterate through that list of tuples of the keys and the values. Now, if you're using Python 3, what you want to use is .items. So that's going to .items for Python 3 is going to be the same as using iterItems in Python 2. It's basically a really similar change as when we were learning about range and X range, which we'll cover in more detail throughout this course. But a lot of the changes in Python 2 to Python 3 were turning things into generators, so you wouldn't have to store things in lists. Okay, so you might be wondering why this worked in Python 2, and that's because of the introduction to generators in Python during its earlier years. So go ahead and read this in the Jupyter Notebook. Hopefully you already have before coming to this lecture, but it's just a little more of a breakdown as to what's going on here. But let's go ahead and say a quick tuple unpacking for a dictionary. So I'm going to say for kv in d.iterItems prints k prints v. And there I'm printing every key and every value. And it actually doesn't matter whether or not you have these parentheses in there. It's going to work the same. So that's actually up to you. I just put them in there because it might be a little more clear that you're doing tuple unpacking. But if you're reading someone else's code, more than likely you're going to read it like this, just without any parentheses, the k and the v, or whatever the items happen to be in that tuple. Alright, so that's it for this lecture. Go ahead and make sure you go over all the examples in the Jupyter Notebook. They're really similar to the ones we did in this lecture, but just make sure you understand the context of a for loop and how to make your own for loops. All right, thanks guys.